The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC&R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max Press to Connect, and Zoom Lock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your host, Wetzel and Kevin Compass. What's going on this week, man? What are you doing?
Oh, a lot of BS work, kind of prepping for more of these island installs. And then yesterday I was putting economizers in rooftops that never got ordered with economizers. So we did a big rooftop sweep at a store chain, and we had to install a bunch of economizers, which, by the way, sucked ass.
Why so? What manufacturer?
They were Carriers, and you have to take the whole fucking unit apart. It's not like just putting a hood on. They didn't have the louvers, the dampers, the wiring, anything in there. So you got to install it all. It comes in this giant kit, and you got to take the whole damn rooftop apart to get it in.
Yeah, but it usually mounts up pretty good. As far as how big are we talking? Like a 5-ton or something bigger?
No, these are 25 tons we were putting them in.
Never mind.
And they're on a curb adapter, so they're up in the air a little bit. Yeah. It was not fun. And then there's 3 journeymen looking at this thing for 20 minutes trying to figure out why the panel won't fit. I'm looking at it, I'm like, these are not the right panels. There's 5 of the same rooftops, and I go grab one from another rooftop. I'm like, okay, it's the right economizer, but not the right the skins for the rooftop. I'm like, oh, you gotta be kidding me. So we had to take the whole damn thing back out and back apart on one of them and put the original skins back on it because they sent the wrong ones. And of course, they were it took 3 months to get them.
So it's going to be another 3 months before those other ones come back in.
Yeah. So again, another 3 months before we can close the job out again because the manufacturer sent the wrong stuff.
Yeah.
So was doing that, and then I got whacked in the back with a roof hatch and almost went falling down the roof hatch. To the point, my back is like black and blue. Looks like somebody hit me with a baseball bat. The roof hatch was broken, and the wind just kicked up, and like right as I was coming up, the latch came down, and like it had this like hillbilly welded on like lock latch, just speared me right in the back between my shoulder blades.
Awesome.
Yeah. Yeah. Almost a recordable. What about you this week?
I'm actually down in Houston. I totally, with Mother's Day, I totally forgot to book my travel. I mean, I drive down to Houston. It's about a 4.5 hour ride. And I decided Monday to finally go. And I'm trying to finish up. We're opening up a courses like commercial classes, and basically trying to get all the equipment in there and all set up. And then we're also making it that the 6A and B classes can be in Houston as well, because then I don't have to fly them all out to California all the time, and getting all the electric ran for everything else that I'm going to need. So it was funny. I think it was, when I first got in Tuesday night, I went back to the shop after I went to go get something to eat. So I wanted to drop my tools off. So I was not in an area that I'm usually in. So I don't know it. So I was like, let's just empty out some of my tools. So I brought a whole bunch of shit down to work on all those panels. And I go back over there to put my stuff in. I go to leave. Sure as shit, all of a sudden, Houston just got gnarly with lightning. Something hit like right next door because it scared the utter shit out of me. I probably jumped about 4 feet, and then the power went out. So I couldn't get out of the shop for an hour. So I was kind of stuck.
You have tools still?
Yes, we do.
All right. So what are we talking about tonight?
All right. So this came up. It was at first when I was talking to someone, they were like, "Oh yeah, it's the one with the big green tank." So automatically, I assumed that was the liquid pump overfeed. But Hill Phoenix happens to make a model number. It's an SNMT2LX. It's actually a combo liquid pump overfeed and Cascade, all built in all together. And it's interesting because if anyone's ever worked on the liquid pump overfeed at the Walmart, typically those guys all have low temp compressors on there because they bring the glycol temperature, or I'm sorry, the CO2 temperature down to -20 or -22 or something like that. And they're able to refrigerate their low temp. So on this one's just a little bit different. It's still utilizing an HFO or an HFC compressor, but instead of having low temps on there, because it's a combo Cascade and liquid pump overfeed, they're basically utilizing the medium temp CO2, like the temperature that you would need. So like they're looking at like, I think 20 degree CO2 temperature, because then that'll take care of all your medium temps. And you might say, well, it might not be able to, because usually you have to be down to 18 degrees. You got to remember on these liquid pump overfeeds, because there's basically no expansion valve. It's just a solenoid that lets liquid CO2 in there. Remember, the lower the superheat you have, the lower the TD you'll have. So where maybe a typical case will only have like a 10 degree TD, but if you flood out that coil, you might get down to a 1 degree TD or 2 degree TD. And that's how it's able to actually still achieve those temperatures of the product needed with only a 20 degree CO2 temperature. So what happens is the CO2 will come out of the low temp compressors and get put into the inlet of these heat exchangers. The heat exchangers, like I said, are running, I think, 16 degrees saturated, so they can maintain a 20 degree CO2 temperature. And at that point, 20 degree CO2 is like, I think the set point's like 420 or 430, somewhere in that wheelhouse. And then they're pumping that out through a heat exchanger and then out to all the medium temp compressors. Well, they also have the low temp on there. Well, if we're already running at 20 degrees saturated condensing temperature, we would need to pull that down even lower. So essentially what they do is they use that same liquid pump supply to feed other low temp cases. But in this instance, they actually have expansion valves. They're actually, or at least they're controlling the superheat on these, which then goes through the heat exchanger, back up through the suction of the low temp compressors, and discharges back into the heat exchangers, and the cycle just repeats. So they're using, like I said, they basically, when coming out of the low temp compressors, because you're going to get a little bit of discharge superheat, and you don't want to overtake those over those heat exchangers. Plus, heat exchangers don't like over a certain temperature. I'm not sure what it is, but they don't really like you putting discharge gas temperature into those heat exchangers. Typically, the de-superheater will come on when it's about 65 degrees outside. And you should be averaging, as far as coming out of your compressors, as far as discharge temperature, in the wheelhouse of probably like 130 to about 120. Then once it goes to the de-superheater, now obviously if there's an ambient de-superheater, it's going to be based off of what the temperature is outside. But it's usually within, I don't know, like at least 95 degrees is, I think, usually what it's actually set for, like going into those actual heat exchangers. A lot of the same principles with these heat exchangers hold true as far as superheat control. If you're looking at all the percentages of all these heat exchangers, they should be within anywhere from 5 to about 10% of each other. If they're not, if they're way off, it could be a multitude of things. One of the most common things with these systems is they're getting bound up with air. Someone got some non-condensables in there somehow, and it basically caused the air is going to rise to the highest point. Usually those heat exchangers are the highest point. So there's actually usually on the inlet side where the CO2 goes in, where it's a vapor before it comes out being a liquid, right there at the very tippy top. That's where they actually have a service valve up there that you could actually blow some of that charge.
So I see less issues with the Cascades doing that than the liquid pumped overfeeds. And I'm not, the systems I've seen, I haven't seen the Hill one, but I've seen like Carnot's version, and I've seen a couple other different versions of it. Basically what they're doing is, it's no different than the Target Cascades, where they have an HFC or HFO cooling it down. Well, they're still doing that, and they're just using the receiver like you would normally have on the Cascade rack for the CO2 side, and the liquid pumps coming off of that. So they're not actually doing liquid pumped. They're not doing the thermal siphon. They're using the discharge gas from the compressors are going right to the heat exchangers. So you have that constant forced volume there. You don't have that lockup, is from what I've seen, from what the systems I've worked on.
Oh, so you're less likely to get the non-condensables, right? Oh, okay, I see what you're saying.
Yeah, because it's you're pushing through it. It's not like it's the thermal siphon where it's just working on that principle of cold it's gonna attract the CO2, it's gonna attract the vapor and drop out liquid.
Yeah, but you're still gonna, like, in order to get those non-condensables, that you still would shut down the system, right? At least shut down the low temp stuff and then the medium temp stuff to basically get all that air to rise into those heat exchangers.
The heat exchanger or the vessel's usually the highest spot. So like usually it'd be no different than charging or purging a normal rack.
Yeah,
which you overdo.
Gotcha. Now remember, these still have the down towards the cases. We still have the standard CO2 ball valve setup where you either have a ball valve with a check valve in parallel with it. So in case you were to shut it off and the pressure would rapidly increase, it has a way back around through the ball valve so you don't end up blowing out that coil. Because, I mean, for example, if you're at a negative 20 degree CO2, that's 210 pounds. So if you blew out all the vapor, or you get the vapor down to whatever the suction pressure is, and you start hitting that with a hot hose, there's a high probability that temperature could go up to, or pressure could go up to at least 1,000 pounds. So that way, in case it does do that, it can find its way back up to the rack. And they do have other valves. Sporlan has their own valve. They're marked with an A and B. The A is going to be typically towards the store side, because the check valve is always pointing back up towards the rack.
Unless you're in a zero zone case, and then it's backwards.
Really? Why?
Because their coils are on the other side.
Mm-hmm.
Let me tell you, I felt like a real dumbass. I'm sitting there and I'm like, I was checking a store it was a transcritical store. I was checking wall valves before because I've got a habit of doing this, making sure they're all the right direction so we don't have any problems. And I'm through all the Hussman cases. Okay. They had like 4 backwards, so fix those ones. And I go zero zone cases. I'm like, son of a bitch, they're all backwards. We're on the opposite side of the case, and I'm looking. I'm like, oh shit, the TXVs are on the other side of the case. so they're flipped around. But like, I mean, if you look at those Sporlan ball valves, it's kind of confusing at first because like the way they got it labeled, it's kind of hard to read the direction, especially on a ball valve. You gotta download the PDF and actually look at it and look at the way the ball valve is sloped. So that's the easy way to do it. The other thing with these systems, guys, so you could have a couple different types of metering devices. Okay, so on the low temp, which is going to be your compressed side, meaning like you're going to be using compressors for this. On the low temp, you're going to have either a pulse valve or you're going to have an EEV. Hopefully you have EEVs. EEVs provide way better control. I mean, if you have pulse valves, it is good.
Well, no, all I was going to say is I understand what you're saying as far as control, but I think they're starting to use pulsers because then they don't have to put a solenoid. Because here's the thing with the electronic bipolar steppers, they don't go back to zero when they shut down. So they need a way to do that. So when they're doing that with CO2, they should always have a solenoid before then, because if God forbid the store would lose power, that refrigerant would just keep migrating right through.
I would rather it do that. I don't want it to shut off.
I'm just saying.
So here's my take on that. It's 2023. How is there not capacitor banks on valve drivers?
Yeah, I don't know.
But certain valve drivers do have it. Like the Emerson Dixel stuff, you could buy a capacitor bank, like valve battery, basically for those to drive and shut. I'm almost positive the microthermal ones drive shut.
The Beacon ones do. The QRC.
Yeah, I'm almost positive the MT ones drive shut.
I don't know. We're gonna have to ask Charlie.
Yeah,
but
I know on the 700 boards you could buy a battery. There's a battery supply backup that go on the, at least on the rack boards for that. But I mean that stuff should be backed up. I mean, it is what it is. But like, I get that. I get the pulse valves, but like, I don't know. They cause such poor control over what a stepper was. And I mean, CO2, that's everything. So back to this. If you're gonna be using the Cascade style with liquid pumped overfeed, you're gonna have either stepper valves or pulse valves on a low temp. You're gonna be a standard DX style. Like you have a compressor's compressing it. You're pushing it down. You're going to be running the suction pressure anywhere from 200 to maybe like 220 is going to be your suction pressure. You're going to be running like a normal DX refrigerant would, basically. Now, on your medium temp, this is where it gets a little weird. Okay, you could have stepper valves. You could have CDS valves. I've seen CDS valves be used, or you're going to have solenoids. Your most common is going to be solenoids. Now, what this I think it's an XSP.
XHP, I think.
XHP. This is the Sporlan CO2 valves. Now, the solenoid valves, they're an orifice solenoid valve.
Mm-hmm.
You're either going to have those, the Danfoss ones, I don't know the part number on those, or you're going to have steppers. Now, on the medium temp side, think of it like a glycol. So all we're doing is taking refrigerant, or I'm sorry, not for refrigerant. You're taking CO2 from the receiver / vessel, because it's not a flash tank at this point. A receiver / vessel, and you're taking that liquid that's at, say, 400 pounds, which would be like roughly like 18
on this set point on their settings for the hill rack, they have it set for a 450. So you're going to be maintaining just about 20 degrees saturated, even.
Yeah, whatever it is. I mean, if it's hill, I mean, it's whatever you're trying to maintain that medium fluid at. So say if it's 18 degrees, we'll say it's 425, for example. Okay, you're pumping that liquid CO2 at 425 pounds through the store. Okay, it's pumping through the store, and it is cooling the cases, and then it's coming back and dumping it back into the receiver.
Yeah, the high part of the Cascade system, the HFC and HFO part, is basically just exchanging the heat from the Cascades out to ambient. That's all that's doing.
Yeah, I mean, it keeps it the whole like thought process here, guys, is to keep the refrigerant in one spot, just like the glycol racks. It's reduce the charge, keep it in one spot, and there's less chance of that HFO or HCFC leaking in one spot than it is having an entire store full of refrigerant. So that's the whole goal here. And then the other part of it is they're installing these racks more so, like you're going to see more than we would. They're installing these more in areas where transcritical is going to cost more to run. So this all comes down to a cost aggregation, whether it's cheaper to run a Cascade rack or it's cheaper to run a transcritical rack. I mean, it really depends on where you are. Like I'm up north, transcritical beats a Cascade all day long. So
and they're trying to get rid of the higher GWP refrigerants. So, I mean, unfortunately, right now in California, you can't have anything over 150 GWP, and it can only be, if it's over, it has to be only 50 pounds. So that's why it's trying to reduce the amount of the refrigerants they want to get rid of, right? That's why they're starting to come out with all these lower GWP refrigerants. Yeah.
Even at that, like in California, like even with that lower GWP stuff, you're pretty much screwed. Like, so it just shoots Cascade out because the Cascade is going to be more than 50 pounds. So, I mean, that's why like those areas are being forced to CO2. I think, can you even install a supermarket that's not CO2 like in California?
I don't think so. I really don't think so. They're starting to make other refrigerants. I think Honeywell came out with one or two. They're an A2L, but they need to be the charge max. I think is only like 260 pounds, and it runs way different temperatures, like our pressures. They said it's comparable, almost like 134A or R12 pressures. So even if you had something and you wanted to try to convert it, you couldn't because you'd have to change out your piping, compressors. There's all your velocities are all messed up.
Yes, I mean, pretty much stuck.
Yeah. So on this particular rack, we're going to run probably about a 17-degree midpoint. So about 43 pounds if you're dealing with 449 or 448. And then the heat exchangers set point for the superheats typically usually about 6 to 10 is what I've seen on that. Some people put them up a little bit higher, especially if they're having loading issues. These racks on the HFO side, I don't really see VFDs on there for the compressors. Typically you'll have the Bitzer digital unloading modules. You can have the Siemens style one that takes a little memory card. Basically what it does is based on the compressor you have and how many unloader heads you have on there, it converts a 0 to 10 volt signal to how many times it's going to pulse those solenoids to make sure you're getting the either the most or least capacity out of that, so you have full unloading on it.
Yeah, you're going to start seeing those Bitzer digitals a lot more because I'm pretty sure they just get approved for the CO2 compressors. So I'm pretty sure you're going to start seeing those a lot more because obviously that's going to reduce the cost of VFD. But like, I don't know, I think in the CO2 side of stuff, like I'm not exactly thrilled to see that. I think VFD is a great idea, but also we have the harmonics issues. So, I mean, that digital may make the harmonics go away, but then you also make the control for the actual superheat control worse. Because I mean, your process variables changing all the time, meaning your suction pressure.
Yeah, absolutely. On these racks, in parallel with the vapor liquid separator, as they call it, is a refrigerant tree, basically a pipe that goes up from the bottom and then to the top of the vapor liquid separator. And it has markings on there for 5, 15, 25, 50, 80, and 90. Typically, you want to get these charged up to 80%. That doesn't mean 80% running. That basically means you shut down the master defrost switch where everything will start pumping out. Theoretically, the system should get up to about 80% and shut off. That's where it really wants you. Usually you'll see these racks on the liquid side be above the 15, anywhere from 15 to 25. 15 is actually where you get the warning. So preferably 20 or 25%. And then 5%, if it gets down to 5%, there's actually an alarm setting that will actually, I think it shuts off all the cases because it thinks that it's almost empty on CO2.
It shuts off the pumps first.
Yeah. And those vacuum, or I'm sorry, the refrigerant tree has these, I think they're made by Westermeyer, little photo cells that are powered with 280 volts. So just be mindful of that, because they can short out. When they short out, they hurt. So just be mindful of that.
I caught one thinking it was a DI.
Oh no.
Yeah, I went to go change one and I thought it was a DI, and because I was told it was DI, and I cut it with a pair of scissors and lit my ass up.
So the high pressure settings on this rack, 550, it's gonna cut in, like basically shut down the rack, and 490 it'll cut back out and let the rack run again if it keeps going off on that high vessel pressure. Usually when you're getting that, it's usually something wrong with one of the superheat controllers, sensor being off, pressure transducer being off. You can have, like I said, non-condensables on the CO2 side, because then basically you have refrigerant going through and maybe flooding out and then causing the pressure to be higher. That it's also going to be dependent on your suction pressure of your HFO, right? So that's controlling the actual vessel pressure there. And if you're not within tolerance, or if you have a lot of movement there where you have unsteady pressures, that could be another deciding factor whether this rack goes off on high vessel, because of those laggy pressures where you're going to have the rack turning on, shutting off, turning on, shutting off.
Yeah, so it sounds like what you're describing is like a liquid pumped overfeed hill rack, basically, is how they're doing it. So like I've seen the Carnot version where they have, like, the ones I've seen so they're a little bit different. Like I said, they're using the HFO to cool the actual plate and frame heat exchanger, and they're just the discharge of the compressor through there, dumping the cooled liquid CO2 into the receiver, and then using that to pump it out. And they just use the recirc to dump in the receiver, and then it gets pumped through the system. So that's how they're doing it. But you're saying yours is like a liquid pumped overfeed, so it's not much more different than a Walmart rack. What you would see at a Walmart.
It's a Walmart rack with CO2 low stage compressors, so they can get that. Because you remember, if that vessel's at 20 degrees or 450 or whatever, we need to get that down lower to -20 saturated, right? And the only way we can do that is sucking down the pressure. So we do that with those compressors.
I mean, that's a way better setup, I think, than what they run in the low temp. Just for the fact that, I mean,
compression ratios are going to be ridiculously low on both ends, the HFO and the CO2.
Well, the other benefit is, like, I see, like, so like all the Walmarts right now, we have all these problems. These stores are like 8-9 years old now. Get to 10 years, all the Armaflex is shot because it has -20 degree CO2 floating around the entire store. So any little crack in the Armo just instantly starts to grow ice. So it becomes this nightmare with it. So like, I'd rather have medium temp 20 degree CO2 floating through there. So you're not going to build that ice in condensation in there. It's going to be like a normal suction line on a medium temp. You're not going to have the issues you would have with low temp doing it.
Yeah.
You're not going to build the ice. It becomes a problem. So let's talk about defrost. So defrost of this, you're stuck with two types of defrost, either off cycle or electric defrost. So walk-ins with like standard rod heaters in there for electric defrost. And then off cycle on the Cascade side, you are going to have your just standard off cycle defrost. You're either going to shut a solenoid off, an EEV off, or you're going to shut a stepper valve off, depending on what you have. Now, when you get to the low temp side, it depends on what you have. You can get a little different here. You could run hot gas defrost if you have it, because you are running a low pressure now. So you can run hot gas defrost. So you would have a differential valve before the vessel, or before the heat exchangers, and in between the compressors and the heat exchangers, you'd have a differential valve, and you'd be running hot gas defrost. You could do it much in the same way that we do normal hot gas defrost, because your pressures aren't extremely high. You're talking, you may be at like 450 pounds coming back, and then.
But how do you do that? Well, hold on. How do you do that though? Because 450 is only 20 degrees. So your suction pressure isn't going to be but that high, or your discharge pressure on your subcritical compressor. So how are you doing that?
So there is no discharge pressure in the subcritical, or if the subcritical compressors is going to be, we'll say it's like 400, say it's like 400 pounds. For
Well, that's what I'm saying. The saturated is that low. How are you going to get any heat exchange?
it's all about discharge superheat. So it's they call it latent. It's basically latent gas below freezing defrost. That's how all the Carnot racks are at Costco. So they run a latent. They run hot gas defrost off the low temp compressors.
Yeah.
Run a latent. It's basically a 20-degree saturated temperature defrost, and you got to remember you're still going to have some discharge superheat there. So, I mean, that's why
it's going to be 100, like I said, 120, 130 degrees.
So it's going to be no different than using cool gas defrost. It's going to be a little bit better than cool gas. Think about it like a Husband rack. I mean, you're throwing 70-degree vapor in there.
Yeah, all right.
You're throwing 100. Now, does it work good? Absolutely not. You're extending like defrost off for like 40 minutes, some of them, to do a coil. So it's best, but it's free. So it's a way of doing defrost. Is it the most efficient? No, but that's why like Carnot tanks their suction pressure down to like minus, say if you would need like minus 25 and the bottom, they're running minus 35.
Damn.
They need that compression, a little bit more compression ratio to make it a little bit more
discharge superheat. Yeah.
And the same thing for the coils a little bit, because they want that suction gas coming back to be a little warmer, so they get that discharge superheat for defrost.
Yeah. Today's episode is sponsored by the RefriShield RDP series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
So, I mean, it's below, I call it below freezing defrost, because that's what it is.
Well, that's why I was curious. I mean, you get a little bit of discharge superheat, but not that much. Some of these units also, by the way, they do have an auxiliary condenser. It's basically used so if the power would go out, that auxiliary condenser working off a generator can bring the pressure down below the relief, so it doesn't pop the relief. You'd actually just would have to use a high pressure, like a 410A fan cycle switch, because basically you're going to close on a high, letting the liquid line solenoid come on, and then let that system actually pull down. And usually you set those for, 50 pounds, usually 50 pounds less than what the first relief is set for.
I've only ever seen one customer install the generator and the backup unit. Yeah. I don't know why not a pushed more thing. Total cost for after the second year of ownership, it probably would have paid for itself.
Yeah. The other different thing on this, the ones that I've seen has been controlled by CPC, and usually like any kind of CO2 rack, whether it be regular Cascade or liquid pump overfeed, like everything as far as when it comes back on, the cases are usually staged within times via the control program. This one Hill Phoenix rack that I'm speaking of, the one that I've seen, it does not. It actually, they turn on all the cases all at the same time with one relay. They actually utilize the shutdown for the rack to they actually have all the multi-outs connected to all the enables from the phase loss. So if something happens to the rack, it just shuts down all the cases. But how it turns it back on is when it does turn back on, there are, I think, 6 different relays, timing relays that are set for certain times. Like if you actually look within the schematic, it'll show you, okay, this one's supposed to be set for this time. This one's supposed to be set for this time. This one's supposed to be set for this time. So you don't bring on all that load all at once, especially after a potential failure.
Probably all crews that time delays, and every time there's a power outage, probably half of them are out.
Yeah, it happens. On the liquid pump side, just so you're aware, the piping is done a little bit differently. They have to have inverted traps on the riser and on the liquid because it's being treated more like a glycol. So that's the way that the manufacturer wants that piping.
Yeah, I mean, and when you're the piping and the cases and everything, guys, you're going to be sending liquid down there, and you're going to have a liquid vapor mix back on the medium temp side. It's not going to be 100% boiled off because you're treating this like glycol almost, but it's going to absorb heat and boil off. So you're going to get that liquid phase change, but you're not going to get all of it. It's going to change state, and that's where you get that efficiency at in these coils. Is you still get that liquid phase that phase change, but you're not going to get all of it. You're not going to boil off all the liquid. You're going to have a liquid vapor mix coming back to the tank.
Yeah, I mean, you can have the superheat down to absolutely nothing. Because remember what I said. Think about when you guys are adjusting frozen food cases. Think of it that way. If I were to have one where I'm open up that expansion valve all the way the hell open and get 0 degrees of superheat and compare it to one that's running 3 to 5 degrees of superheat, I might have like a 10-degree TD on the one case, but with the one that I'm flooding out, that TD might get all the way down to like 2 or 4 degrees. And if that's the case, then it's almost a straight exchange. There's so much liquid being in contact with the heat from the product.
Yeah, that's like how like Carnot does an intercooler.
Mm-hmm.
On the medium temp, you could basically flood the shit out of the medium temp, and everything drops into the intercooler because it's an intercooler / accumulator. Everything drops in the intercooler.
Mm-hmm.
Liquid coming back drops in the intercooler that they fill up already to 20%, and then that's your liquid supply going to your low temp. Much like
what?
Ammonia. How they have the intercooler.
Yeah, well, that's what I was just about to say. So, like in more industrial settings, they'll have, and I know you've probably seen this set up on some of the screw racks. They'll have a horizontal receiver. In industrial, they call it thermal siphon. So, and then what they do is they use that liquid that gets caught there first to actually feed like an oil cooler, usually for industrial or any real screw. And then whatever does boil off goes back up in the condenser and gets recondensed into the discharge line. And that's basically how that system works. And then after that, whatever liquid is left out that's overfilling the thermal siphon, that'll just go down to your liquid receiver at that point.
Yeah, see, like Carnot uses the intercooler, and everything coming back from the medium temp goes through the intercooler. The intercooler is at medium temp suction pressure. Now you're feeding the low temp liquid from the intercooler. It keeps the liquid level in the intercooler at 20% to feed the valves normally. So you got that constant boiling. So that way you're only feeding the liquid pressure to the low temp at like 400 pounds.
Mm-hmm.
It's like, say, 500 pounds. It's for like a transcritical rack. You're not giving it that 500 pounds. You're giving it like 400 pounds. So you have less of a pressure drop. You don't have that huge pressure drop there. And then they're also utilizing it to grab any liquid coming back from the store, and it drops off in the tank and gets sent back out to the low temp fixtures.
Correct. And the same rules apply when you do have a flat system. You charge it up to, after you pull the vacuum, obviously, you charge it up to 100 pounds of vapor. I say 100 pounds. Yeah, I know what you're going to say, and whatever. But then once you do that, then you start adding your liquid. I'm not, no, bad practices. Don't do it.
Just send it.
Done.
Works 50% of the time every time.
Mm-hmm.
Just, I mean, when you're charging those, it's going to be the same way it's charged a thermal siphon. So everything valved off, and then let it go to 80%. And once it's at 80%, you can start running.
Just send it.
Yeah. I mean, but with the low temp compressors, you're going to be a little bit different. I mean, you could probably charge that with a running level. Yeah. If everything was running and you had all the cases on, I'd imagine you could probably charge it to a running level. You should see a way steadier receiver level on that than you would a normal thermal siphon, because I mean, you're going to have that compressor load on there, your load's going to be a lot more constant, I would think, on that side of it. So you should have a more steady receiver level.
Yeah. Also on these subcritical compressors for the low temp, especially if they're bitzers, be mindful. There's a piece that's in between the service valve and the compressor body. It's a strainer, and it only has a strainer on half the side, and the other half it's a piece of steel. Make sure that strainer is in the proper direction. These are suction gas cooled compressors, or at least need to be. And if they weren't suction gas cooled compressors like a K body, you need to have a fan blowing across. Well, this little strainer piece will actually divert the refrigerant coming back from the suction either back towards the windings or up towards the front, right towards the head. We had found 2 on a brand new rack that were in backwards, and you could legitimately see what the temperature, like one was sweating, that was correctly put in, the other one was not, and it was because it was basically the suction gas wasn't going through the windings, which will cause the compressor eventually to go off on proof fail, because it'll cut out that Cure 1 module on discharge temperature.
So that's interesting. I had never dealt with that before until actually Greg brought it up to me.
Mm-hmm.
And I could not find the Bitzer literature about that, about the what.
Yeah, I found it. We ended up having to get it from, they had to get it from Australia.
Really?
Yes.
So is that only on like foreign are those?
No, it's on any of the ones that have the, I'm gonna bring up a picture here in a minute. Any of the ones where the service valve is not directly not in the rear end of the compressor.
So basically all the subcritical bitzers then.
Correct. Here, I'm gonna share this right now. Present. Share screen.
Yeah, because I had never heard of that before till now, but we're just
see how it's right here, right? So this diverter piece will either let the suction gas go towards the heads, or it'll make it go towards the ass of the compressor. The 2 of the ones kept, I guess, going off on proof failure, the ones that Greggy found. And, once we turned it around, he actually took temperatures with the thermal imaging camera, but he took a picture of the thermal image. It was like glaze on the picture, but it was at least, I think, 30 or 40 degrees lower than what it should have been.
So did he put it pointing towards the head then?
No, towards the ass of the compressor, because the windings were getting the heat.
Oh, okay.
Yeah. So here, check this out then too. So if I blow up this picture, you'll actually see what the hell I'm talking about here. So very cool. And then because if you put it towards the windings, then it's going to cool off the windings. If you don't, you know what I mean? Otherwise, it's going to go right towards the front. If it goes towards the front, it's not going to cool the windings and essentially cause that compressor. Like I said, it's comparable to having a K body, because those are air cooled compressors. That's why it's always sitting in front of a condenser fan, right?
So dumb. Like, you think they would just not put that in there like that? It's just one more thing for somebody to fuck up.
Yeah, I know. They should just always make it be a suction gas. I don't know. I don't know. There's got to be a reason why they're doing it. I don't know.
I would not want the vapor going to the head first, because it's going to go kablamo like the 06, like the compound cooling compressor Carlisle's, where it goes into the first stage and just fucking sends her home with liquid.
Yeah, like I said, I gotta find the pictures, but Greggy sent me a thermal imaging camera shot where it had to be running like 40 degrees cooler than the compressor right next to it.
With it going into the motor cavity. I mean, it makes sense. I mean, it makes complete sense. I mean, but
you're adding heat with the electric motor running.
But it seems like a bad design on their part, because like no matter what, if it's not going to the motor, if it's not getting any cooling, I mean, you would almost have to have a condenser or a fan blowing on it to do that.
I've seen, or like you've probably seen some of the old Copelands that were like that, but they had water jacket. That's why on those they're real ribbed, so you can have actually water going around that, because that's another option. You could be air cooled with a fan, but you could also do water cooled, where they ran water around the actual jacketing of the compressor.
They say water.
War. I know. Philadelphia. I get it.
Yeah. No, but that gets that I didn't know anything about that until like Greg actually said something. But we're just now starting to see the bits or subcriticals. Like most of the subcritical stuff I see for like the CO2 side of it is Copeland scrolls.
Scrolls. Yeah, you were saying those are all the Aldi's, right?
Yeah, all these have them. Trader Joe's had some, but I would much rather have bit recips on there. Like Copeland's been put some recips on there too. Like I would rather have a recip than a scroll, just for the fact that you could rebuild it.
Your recip.
So, I mean, you could have 410A scrolls while you're doing this too, guys. So let's keep that in mind. Like if you have a different rack, they could use 410A scrolls. Be using 410A scrolls for the subcritical side.
I have a question. So I've read, oh my God, in the past 4 months, I've read so much different CO2 shit. And like, there's some manufacturers out there that say that they have balancing valves for the liquid pump style overfeed system. So in case your piping isn't directly even, you have that you can modulate that flow a little bit. Have you seen the isolation valves?
So I haven't seen the isolation valves, but I've seen CDS valves used.
Or balancing valve. It's almost like a circuit setter. It basically does both. You can shut it all the way off, plus it's a balancing valve. And they put it on the CO2.
So I wouldn't see why it would be a problem. I mean, there's buildings. So say you're running 400 pounds of pressure. I mean, there's buildings that high.
Yeah.
With pressure ratings with water that high.
Mm-hmm.
So I mean, I'm sure they're out there. I'm sure there's balancing valves. I've seen CDS valves be used.
Yeah.
As separate because they're able to slow the flow down going through the cases and give you that like perfect discharge air. That is the perfect application for a CDS valve.
I agree.
You could get that perfect discharge control and also keep the vessel, good. But again, this type of control is one where you'll have to float the vessel a little bit because just like the Walmarts, if you're running minus 20 all the time, you get a bunch of cases shutting off. Now that load drops off and you get spikes because when that load comes back on, it's going to spike the liquid separator / receiver. It's going to spike in pressure and then the Cascade rack has to catch up to it. Gotcha. So that's where you're going to have these issues you want to float that Cascade rack up as high as you can get it to keep all those cases running. But at the same time, you got to watch because you don't want to start high heading the low temp discharge of the compressors because you got that fine line to walk.
Yeah. I get it. I've never seen it yet. I would think it would be less prevalent happening on the medium temp ones, but I wonder if they have the same icing issues where you get that oily, frosty junk in the heat exchanger. And then it causes it to cause that pressure drop. I wouldn't think so. I mean, you are running 20 degrees, but I mean, it's still below freezing, but I guess it'd be more prevalent in the ones that are running like negative 26 degrees saturated.
Yeah.
Regular liquid pump overfeed.
I wouldn't think they would have that problem on the medium temp side. I think that's more of a
low temp one.
It's a low temp oil issue. I mean, it's running such a low saturation. I think it's at the point where the oil is starting to
slushy.
Yeah, it gets slushy and then it clogs up that heat exchanger. I mean, me personally, I hate that heat exchanger there if they got rid of that damn thing. I mean,
you know why they do it though? They're trying to run a lower superheat but not damage those fucking compressors.
Yeah. I mean, that's where they need a bigger accumulator and or a heated accumulator.
Yeah, but the bigger accumulator means more charge. And if they're using Cascade, that's the reason why they're doing it is to get reduced charge.
We have 2 stores up here, it's the only 2 that I know of. They run the liquid line through the accumulator. Works phenomenal.
Either that or even hot gas, because it doesn't really cost you anything. And if anything, it's lowering your energy bill because you're lowering discharge gas off there.
Yeah, I mean, running some. The only thing you got to watch at that is like you'd have to have some kind of 3-way valve or something because you couldn't run the discharge gas through the accumulator all the time because obviously you're going to. So, I mean, you would have to have some kind of loop in there, like a de-superheating loop in there
With like the LMB racks where it bypasses with the EPRs and shit.
So that would probably work pretty good. Like in that scenario, that would probably work pretty good in order to keep it from doing that. Like I just don't think the inline 2 1/8 heat exchangers are the answer. I mean, that's to me that those things cause more problems than they solve. So with the oil like locking up in there, but I don't think you're gonna have that on the medium temp HF.
No, I don't think so either.
No, because it's not gonna run that cold. So, I mean, other than that, I mean, the charging should be pretty close to a liquid pumped overfeed. The only thing you're gonna have to watch is make sure your compressor safeties are all set on your low stage compressors, or you're gonna be popping reliefs. And then, I mean, you should have less reliefs on there. You should only have reliefs on the lines and then the flash tank. So it shouldn't really be that big of an issue. The pumps, guys, if you run the pumps dry, they're SOL. So I mean, you need to make sure that 5% like cutoff works and shuts off, because if you run those pumps dry, you are SOL. Those things are hard.
You're gonna have a bad time. They're made out of Germany, and like if you go all to Phoenix, they're gonna tell you it's gonna be built to order, right? If they're the Grundfos ones, though, there's a couple places around the United States, and it's the same exact footprint. It's actually there's no difference. I had 2 go bad, or one was bad, and then the other one went bad, and so we had no liquid pump overfeed on anything. And sure as shit, I called this place down in Houston. They had 2 or 3 of them just sitting on the freaking shelf.
Yeah, they are not cheap.
Mm-hmm.
Like $5 or $6 grand a piece.
Nope.
Yeah.
Nope. But I mean, for the most part, unless you run them dry, that's the other reason why they have there's a differential setting on there, that if it doesn't maintain more than like a 10-pound differential from the vessel pressure from the pump discharge, because the pump discharge is going to probably bump that pressure up probably about 35 pounds or so, depending on the load, depending on how many cases are in defrost or whatever. But yeah.
The other thing is, like, these are very important to make sure they're going in the right direction. They will burn up very quickly. So the only way you know they're going in the right direction is usually it's maybe like a 1/2 amp to 3/4 amp higher when it's going the correct direction.
Mm-hmm.
So you'll have to do is bump it real quick. I usually just jam the contactor with the screwdriver quick second.
You won't have a differential either, though.
It's hard to tell, though, because you'll have a little bit of a differential. So it's not going to be 35 pounds when it's running. It's going to be like most of the ones I've seen have been like 15 to 10 to 20 pounds at the highest. So, I mean, you got to really watch. You're going to have a little bit of a differential, but like it's like a 1/2 amp to an amp more when it's going the right direction.
Yeah.
So, I mean, go ahead.
No, all I was going to say is they utilize, for the programming for these, I'm just saying that they use a lot of sensor controls. So you're going to have to look through, but what's really nice with a lot of their schematics, it'll actually show you an RO. It'll label what the RO is, so you know what part of the program it's for. And then there's usually a little notation. So if let's say the de-superheater that was set for a cut in, cut out at 60 and 65 for the cut in, 60 for the cut out. And that's exactly what it says on the actual schematic. So that's one thing that's really nice about this. The program kind of tells you where it is, but if you match it up with the ROs on the actual schematic, it'll help you so much just being able to understand that.
Yeah, I mean, that is nice. So
I think we're gonna cut it unless you got anything else, boss.
Well, that's it.
All right, guys. Thanks again for listening.